All right, you are welcome to today's class with Anakwe Christopher Jike, your chemistry teacher. Let's enjoy the class together by starting with this. Let's try to name this compound. If you look at this particular compound carefully, you will know that several things are needed in you pronouncing this compound correctly. As you can see that the long chain that have the yellow background or shade here, we call it parent chain. And the CH3, we call it substituent or branch. And instead of methane, we call it methyl. So in naming this particular compound, several things need to be considered. And that is what we call nomenclature. Naming this particular compound follows the rule. Rule of you knowing that the long chain is parent, the extension, substituent, or we call it branch. And in naming it, there is rule we call Iupac nomenclature, the right way to name this compound. You will learn the name of this compound as we continue, but this will lead us to what we call Iupac nomenclature. Iupac nomenclature, how to pronounce this word, the compound or substances, organic compounds, in Iupac way. Iupac nomenclature will be the topic for today's class. Iupac nomenclature. So the Iupac nomenclature of alkane is where we focus on today, because we have Iupac name way of pronouncing the alkane, and several organic compounds. So we focus on alkane today, but with the knowledge of the alkane, how to pronounce compound in alkane, it will give you a good knowledge of pronouncing the alkenes, alkynes, alkanols, and all of that. So this is actually just like the basis for the Iupac nomenclature. So it's expected that by the end of this particular class, you will learn how to name or the full meaning of Iupac nomenclature. The full meaning of Iupac, what Iupac means, you will learn the full meaning. Then number two is that you will study the rules in naming alkane. You don't just see a compound and pronounce it whichever way you want. You pronounce it with rules stated by the Iupac, so that when you pronounce it, it's been accepted in any level, in any standard. Now, number three is that you should now be able to name alkane compounds by the end of this particular class. So we're going to take them one after the other. First of all, what does Iupac mean? The word Iupac means International Union of Pure and Applied Chemistry. Iupac. Iupac, IUPAC, means International Union of Pure and Applied Chemistry. It's established. This particular Iupac, the union, established the rules of nomenclature, rules of naming. Nomenclature just means name. Nomenclature of all chemical compounds. So Iupac actually can be regarded as the systematic nomenclature because of what? There is an overall system and structure to the names. It's a systematic way. It's an organized mix of naming, the overall system of naming a structure or a compound. So Iupac is International Union of Pure and Applied Chemistry. It's a union. All right. What actually is an alkane? We have talked about alkane in the last class, but once again, alkanes are single bonded saturated hydrocarbons with the general molecular formula CN H2N plus 2. That is the general formula for all the members of alkane. With this formula, we generate any the formula, molecular formula of any particular hydrocarbon or alkane you want. Alkanes have only single bonds, carbon to carbon single bond. Their molecules are also open chains molecule. They are open chain. They can be open chain. They can also be either straight chain or branch chain, but they are open chain, meaning that they are not close ring. The alkanes that are close ring, we call it haloalkanes. Haloalkanes, the cyclic one, the one that has close ring, but normal alkane is open chain molecules. This means that they do not have any circles or rings in the structure. They follow their own naming rules. Haloalkanes follow their own naming rules. Alkane, normal alkane, has its own rules. But as I said before, that alkanes, how to name alkanes give us basis for other families, other homologous series in the organic chemistry. So once again, alkanes are the single bonded saturated hydrocarbons with general formula CnH2n plus 2. All right, their members once again, we have done it before, is C4, CH4, that is methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. That is for the first 10 members. Actually, in your secondary school or in most of the classes, what you expected to know closely is this particular first 10. This first 10 is what is expected of you. Now, knowing till 20 is just a additional knowledge of that, but you just need the first 10. It's actually being required oftentimes. But the other 20, from 11 to 20, is just an additional knowledge, which I will add that in this particular class. From number 11, we have undecane, duodecane, tridecane, tetradecane, pentadecane, hexadecane, heptadecane, octadecane, nonadecane, and isocane. Isocane. Number 20, isocane. Now, when you look at this, you observe that undecane is 11, duodecane. Now, sometimes it could be written DUO, DU, or DO. But you observe that all of them, we just have prefix being attached to decane, which is number 10, undecane, duodecane. Tri is 3, tetra 4, penta, that means 5 plus 10 is 15. Hexa 6 plus 10, it gives you 16, just like that. So naming from 11 to 20 is not a problem. It's not a problem, but it's just an additional knowledge. You just need the first 10 of the alkane family. All right, now let's look at the simple rules we need to follow in naming the compounds. Still know that our interest here is naming the alkanes. This one we started with. Now let's look at it. As I said before, the long chain is what we call parent chain. Just know it. The longest chain of the compound or structure is called parent chain of the particular compound. Then the substituents, we call it branch. Substituent CH3 is methyl. It's a substituent. Instead of calling it methane, because methane is CH4, you call it methyl, which is a K group. This is just the few things you need to know. Now let's take the rules. Number 1 rule. What is the number 1 rule you need to note? Identify the longest chain, carbon chain. Identify the longest carbon chain in any structure given to you. That chain, that particular longest chain, we call it parent chain. Now, let's take this particular compound as an example. Look at how the structure is. The longest chain is what I just look at the structure of how I enclosed the longest chain. Not minding that you can see methyl at the end, minding methyl, see methyl in the other end, but that is not the end. The longest chain when you follow the link is what is being circled. So that is the longest chain of this particular compound. I'll pronounce the name, we'll see the name at the end as we go. But the thing is, note the longest chain first of all. So that it will enable you to give you it will aid you to number them. So first thing, identify the longest chain of the hydrocarbon or the structure given to you. Number two, identify all the substituents. That same compound, that same first one. This one, the second thing, this is the first thing, identify the longest chain. Second one, now you can look at this. There are some substituents on it, some attachment on it. We are to identify, that is rule number 2, is to identify the substituents in the group. This time around, look at the substituent in the left, methyl. At the middle, we have methyl into 4 places. Then ethyl is 2 carbon atoms. We have ethyl, then methyl is 4. So you need to identify all the substituents there and note them. That is number 2 rules. Then number 3 is for you now. You have to number the carbons. Number that longest chain. Number it from the end that gives the substituent the lowest number. Of course, you're going to number, but you are numbering it. Where one should start is where those substituents should have the barest number, lowest number possible. Because you have 2 ends, one extreme, the other extreme, but start number 1 from the side where the substituent will have lowest possible numbering. So that is what you need to do. If 2 or 3 more side chains are in equivalent position, assign the lowest number to the one which will come first in the name. That is number 3 rules now. All right. That same compound that we gave as an example before. Now let's take a look at it. If you number the first one from right to left, you are going to have substituents like 1, 2, 3, 4, 5, this and that. You will see the position of where the substituents falls in. 3 and the 3 carbon atom, we have 2 substituents. We have 2 substituents there. Then we have another one at 5. We have 2 substituents there. Another one at 8, we have another substituent, which is methyl. Then that is the correct way. If you number from left to the right, we are going to have substituents like 3, 6, 6, 8, 8. You see, the number of the second one is 3, 8, 8, 3, 6, 6, 8, 8. The numbers are more, have a larger figure than the first one. So the best way to number it is the first one. The numbering should start from the left, from the right to the left, based on this particular structure given to us. So that is the 3rd point of numbering. How to number is number 1 we say is that identify the longest chain. Number 2, identify all the substituents on it. Number 3, number the long chain. That is hydrocarbon. Number it, starting from the side that will give you the lowest possible numbering as considering the substituents on it. Then number 4, if the same substituent occurs more than once, the location of each point on which the substituent occur is given. In addition, the number of times the substituent group occur indicated by a prefix. Di is for 2, tri is for 3, tetra is for 4, and all of that. When you look at that particular compound, you observe that the position where the ethyl occurs is 3. And the 3rd carbon atom, that is why we call ethyl. 3 ethyl. 3 ethyl. 3 ethyl, that is the position where the ethyl comes X. Then the next one is methyl, appears 4 places. And the position where they fall in is, the first one is at the 3rd carbon atom where the ethyl is also. Then the next 2 is at the 5th position carbon atom. The next one is 8th carbon atom. That means we have 3, 5, 5, 8 hyphen tetramethyl, telling us that methyl is 4 times, appeared 4 times there. So the compound altogether is 3-ethyl, 3,5,5,8 tetramethyl decane. The longest chain there is 10 carbon atom, which is decane. So it tells us that we have tetra, tells us that we have 4 methyl group in that particular compound. That is the name. So tetra is telling us that it's 4. And when you look closely, you observe that between numbers and letters, we use hyphen to demarcate it. But between numbers, each of them, you demarcate it. Between 3 and 5, we use comma to separate them. But between number 5, between 8 and T, tetra, we use hyphen. Just anytime you have between number and the letter, you use hyphen to demarcate it. And after the substituent, there will not be any space in with the parent chain. You write it together, methyl decane, no space. So that is it. We'll look at it to observe now that the name of the compound is written out with the substituent in alphabetical order, followed by the base name. You see, we started with ethyl before methyl because A, B, C, D. We, of course, you get E before methyl. So not minding the position where it is, pronounce them alphabetical order. Then commas are used between numbers, as I just said, and dash, hyphen, are used between letters and numbers. I just said that now. And there is no space in between. There is no space in the name. After the substituent, no space between that substituent and the parent's name. So that is how we name organic compounds or structure in Iupac name, the Iupac way. All right, then the 5th point we need to note is this. If still remember, number 1, identify the longest chain. Number 2, identify all the substituents. Number 3, we say you should know number 8. Number 4, then in naming, know when it appears 2 or 3 or 4 times, locate the position and put di, tetra, tri, depends on the number, how many times it occurs. Number 5, we say if chains of equal length are competing for selection as the parent chain, then the choice goes in series like this. The chain which has the greatest number of side chain should be given, should be taken. Then the number 2, the chain whose substituents have the lowest number. The next one is the chain having the greatest number of carbon atoms in the similar side. Then lastly, the chain having the least branch chain, side chain. So you need to consider all this. And the number 6th one is that when we have cyclic, that is ring, which is closed chain hydrocarbon, is designated by a prefix. In pronouncing them, we use cyclo. When we have a closed ring, cyclic one, when pronouncing, we use cyclo any compound. This is maybe something like cyclopropane, cyclobutane, cyclo anything. It depends on cyclohexane, depend on the particular compound, but the ring is being indicated with a prefix cyclo, which appears directly in front of the base name. That means in front of the parent, the particular compound that has it. All right, let's take some example. Look at this particular compound. You see, I named it from left to right. Why? Because when you look at, of course, the position, if you name from left to right, the second carbon atom will have substituent. If you name from right to left, second carbon atom will have substituent. But substituent at the right side is methyl. It's only 1 carbon atom, H3. But at the left side, we have the substituent there is ethyl, which is heavier, bigger, 2 carbon atoms. So because of that, you should give preference to left. You should number from left. So the compound here now is what? 2-ethyl. Why? Because ethyl is substituted at the second carbon atom. So 2-ethyl, you put dash. 1 2-ethyl is at the position there. 2-ethyl 5-methylhexane is the name of this particular compound. All right. We can take a look at this. Looking at this particular compound, we can see that when you number it, the numbering is from the left to the right. Look at the long chain. We have only 2 substituents there, and the 2 substituents are the same carbon atom, third carbon atom. So the long chain there, we see that the long chain is 6. That means hexane family, hexane as the parent name. Then at the third carbon atom, we have ethyl and we have methyl. Parent chain is the long chain and it's hexane. So the name of this compound, you start because 3-ethyl it comes first before methyl in the ABCD. So the number, the structure is being named this way iopacally as 3-ethyl is at the third carbon atom, 3-ethyl, 3-methylhexane. That is the name of the compound. 3-ethyl, telling us that ethyl is at the third carbon atom. Then the next one is 3-methyl. Methyl is the third carbon atom also. Then hexane together written with that ethyl. So 3-ethyl, 3-methylhexane is the name of the compound. All right. Let's also take a look at this. Look at this particular compound. And identifying this, you look at how the numbering is. We number from right to left. From right to left. And we observe that nonane is the parent chain. The longest chain there is nonane. And we have substituent at the second carbon atom, at the 6th carbon atom, and at the 7th carbon atom. We observe that what is substituted at the second carbon atom is methyl, 7th carbon atom is methyl. Then the next one is propane. Propane, M comes first before P. So the compound here is 2,7. That means 2,7 is where the methyl group falls in. 2,7, you put hyphen. 2,7 die because methyl is 2. 2,7, 7 hyphen dash die methyl, telling us that methyl is 2. Then 6-propylnonane. The compound once again is 2,7-dimethyl 6-propylnonane is the name of this particular structure. All right. With that, you can look at several structures. Ethene, propene, they are just normal ethane, normal propene. Look at this one. We have 2,4-dimethylhexane. We have 2-methylpropane. We have 2,2-dimethylpropane because it's for the 2-methyl first are the same carbon atom, second carbon atom. We have 2,3-dimethylpentane. These are names of different organic compounds of alkanes. We have 2-ethyl here, 2-ethyl, 2-methylpropane. All right, we have 2,3,5-trimethylheptane as the compound. What have we done so far? We have been able to say that Iupac means International Union of Pure and Applied Chemistry. That this particular union established the rules of nomenclature of all chemical compounds. That alkanes are single bonded saturated hydrocarbons that have general formula CN, H2N plus 2, and the alkanes have only single bonds from carbon to carbon bond or hydrogen to carbon bonds. They follow, their naming follows rule. You don't just name it anyhow, and that full rule is what we call Iupac nomenclature. All right, this is an assignment you are going to be, do. WAEC questions, WAEC 1988, number 13 says, write the structure of the following. 2,2,4-trimethylpentane, ethyl metanoic, trans 2,3-dimethyl-butene. And number 2 says, draw the structure of 2,3-dimethylbutane. Lastly, B, 2B, 1,4-dibromocyclohexane. Just try this particular exercise, and you can further this particular topic by studying through understanding chemistry, new school chemistry, compiled past question and answers. You can contact me through my WhatsApp line 080-655-73229, or you can also email me at christo116@gmail.com. All right, thank you for listening to this particular class. Thank you, and